separator, okay, as commas, or that is also a very common thing. So how do you do that? So strings have a special method called join. Alright, and the syntax is a bit weird at first if you look in other languages, but once you use it, you get the hang of it, right? So what it is I can say dot join, right? So, and I can pass a list here. Alright, so also what this does is this concatenation, the plus operator that we looked at yesterday, it creates a new string every time you add it, right? This is a new string, then that, this is a new string, then this added to this is a new string, similarly this added to this is a new string, right? So it's not very memory efficient doing this concatenation. Imagine this being a for loop of 1000 elements, and you are creating new strings in memory everywhere, right? That's not efficient. So the idiomatic way, the Pythonic way to join a list of values using a separator is to use the join method. So I can say separator, this is a separator which has to be a string, right? Dot join, I pass in the list, right? So this is how you do joining using a separator. And for the sentences above, I can say space. Notice this is not an empty string. It has a space, so it has the length of this string is 1, right? So this dot join sentences, right? It will give you the sentence that you want. It will handle the edge case where if you wanted to create this method by hand, you might add a trailing comma here or an leading comma here. So it handles that edge case as well, and it's memory efficient. Alright, it doesn't create new strings, intermediate new strings. Okay, so this is the idiomatic way to do joins, to join to create a new string with create a something separated string from a list. It doesn't have to be a string, it doesn't have to be a list in the argument, it can be any sequence. So it can be a tuple, it can be a list, it can even be a dictionary as we look, right? So this is the thing that I wanted to cover. Also, if you want to create a new list, we saw this in the morning. This is an empty list. You can pass in a new list, 13, 14. It will create that list as well. What you can also do is you can pass in a string here. See the similarities in this and this. I've been saying that strings are like lists. They are like lists of character, right? So what will this this statement do? Can anyone attempt this in the chat? What will this do? List of right. What will this do? Will it error? Will it give me a new? Will it give me a list, or what will it do? Any attempts? List of characters. Alright. Anyone else? Okay. So what it will do is it will give me the a list of individual characters of the string. Right? Strings in Python are what we call an iterable. Sorry for this. Yeah. Strings in Python are what are called as iterable. Iterable is not a thing specific to Python. It's a design pattern. If you know about those, that was Some people, there's a famous book called Gang of Four, if you want to read about it. Gang of Four book, just search about it. Uh, they invented these design patterns, the things that we do repeatedly in programming, that they gave it a name. Alright, so and I won't go into much more detail here. So strings are what are known as iterable, right? Along with strings, lists are also iterable, tuples are also iterable, sets are also iterable, dictionaries are also iterable. Right? All the basic data structures of Python are iterable. Okay, so what does that mean? That means where I seem to have passed this list, I can also pass any of these. Generally that is true. In some cases that might not be, but in general, where you can pass a string, and the thing is related to iteration or constructors or creating new elements, you can in general pass these things as well. Okay, so let me just give you an example. I can pass a tuple in here, Sean, 22 2021, and I think it shouldn't error. Yeah, did it. I can even pass a dictionary. I think so. I can pass a dictionary. Yeah, we can pass a set as we will talk about set, but yeah. Uh, so in general, look for iterables. Right? This is the keyword that you want to remember. It's an iterable. Right? Sets are not iterable. I think no. Sets are iterable. Sets are so iterable and ordered are different attributes, Lalita. A thing can be iterable, but it can be unordered. Yeah, we have looked at range. So range, yeah, we looked at range, right? Range represents a sequence of integers, right? So what if we passed range here? So I've been telling you, you can pass any iterable here, right? And how do I know that? How do I know that I can pass an iterable? Again, I go to the hill and it's explicitly telling me that you can pass an iterable. Alright. So what if I pass this range method inside of here? Range 0 to 10. Alright. What will it give? Can anyone guess what will it give? I will go to the chat. What will this give? List of range of 0 to 10. Any guesses? Right, I'll take that as no. What I can do is I can do something like this. So this is an idiomatic way, this is a Pythonic way to create a list of integers in Python. Okay? This is how you create a list of integers in Python. Just a minute. This is the way how you create a list of integers in Python, but generally you want them to start with 1, so you put 1 here and you put 11, so you get integers from 1 to 10, right? Remember this slicing logic here. This is inclusive, this is exclusive, right? I can even give a step argument, so I want every second number, right? So it will give me 1, 3, 5, 7 odd numbers, right? This is one way in Python how you can create a list of odd numbers, right? A list of odd numbers till 100. This is how you do that. Better would be to have it till 11. So yeah, this is how you do it. So since this is an iterable, you can pass it inside the list function. Okay. Many things in Python are iterable. Okay. Sets. So what is a set? The first thing to note about set is set doesn't have it's a set, right? Set doesn't have any literal syntax so that you can create a new set. You have syntax for empty list. You have syntax for tuple. Let's just, although this looks mathematically like a set, but this is a dictionary in Python. We'll talk about dictionaries now. But yeah, sorry. With this, yeah. So again, this we can check the types of these type 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 type, right? List, tuple, dict, set, right? Set doesn't have a literal syntax, these square brackets or curly braces like lists and tuples, but you can create an empty set using the set inbuilt function, right? This creates an empty set. So what are sets good for? So sets are unordered collection of unordered collection of unique elements. So in Python, sets are used for majorly two things. One is fast lookup. Second is removing duplicates. Alright, let me just go back to an example. I think it was in the lists, this one. Yeah, let it load. I'll just let me just check if I have those starters. Yeah, I have that in my report. So let's use sentences, right? So I have a list which has elements, which has string elements, and it has Python is sometimes fun, sometimes, right? So you can see sometimes is repeated twice, right? Many a times you want in Python you want to remove duplicates. So how do I do that? There is a simple idiom for that, and I'll just reiterate how to get help. Just use the help function and pass the object or pass the constructor of that without the parenthesis. Yeah. So this is the help page of set, and it gives me this constructor set of iterable, right? So what I can do is, since list is an iterable, I can directly say this, right? What it will do is it will remove the duplicates from my list. Suppose I had is, right, 8. So now I have two repeated elements. I have sometimes and I have is here and is here. Sentence just to see what I can do is to remove the duplicates. Tense. Can see it remove the double sometimes and remove the double is as well. So like I said, this is used to let's just do this again. I apologize. This we'll be using sentences from now. Okay. So yeah, set of sentences. By By the way, if you want to delete a name, you can use delete keyword. The delete statement, you can just remove it and it won't be in your interactive session anymore. So I just would have sentences now. I'm showing my set of sentences, right? Remove blur duplicates, right? So like I said, sets are used for two things: removing duplicates and very fast lookup. So sometimes in Python you want to you want to check whether uh, in a like a million element list, is there some is there a string that is right? Suppose you have a paragraph of million words. You split that using string paragraph dot split spaces. You got a list of million elements. What if you want to check repeatedly in a loop that is this string in my list, is this string in my list? So basically a poor man's search, you can say. So what you can do is, you can obviously say this is in sentences, or sometimes since this is a keyword it might confuse people, sometimes in sentences, right? I can do this. We looked at it. This is a membership operator, right? It works on lists. But if you have a million element list and sometimes is at the index 999,999, so this operation would need to traverse the whole list. So it would need to traverse those 900,000 elements just to reach this sometimes and to check whether this sometimes is there in the list or not. Instead, what we can do, we can optimize this using this. Alright, this single simple line change. What it will do is it will create a set out of all the words. It will remove those duplicates, and if I check sometimes in sit, it is a very fast lookup, because internally it isn't sets don't check membership using going through the elements one by one. They use something known as hashing, right? I won't go into that. Dictionaries also use that, but yeah. So lookup is very fast in sets, right? Here on the REPL it won't look that way, but imagine you have a million elements on the list, and you can save much time using this idiom, right? So remove duplicates and very fast lookup. Okay. All right. Let's go to the chat. Any questions? Okay, 0 to 9. Okay, this was for a previous. Yeah, you are correct. Any questions till now regarding sets or tuples or lists? Excuse me, sorry. Yeah, so we'll move on to dictionaries then. We covered list, tuple, string, range, sets. Let me open dictionaries. It's already open to, yeah. Alright. So what are dictionaries, right? If people have used other programming languages, they might know it by a different name. So a hash map, or an associative array, or many myriad of names that dictionaries have. In Python, they are called dictionaries. So dictionaries are key value pairs, right? So it's a set of key value pairs, and it is one of the most important data structures of Python. Python internally uses dictionaries a lot. Okay, so if you implement classes, if you implement objects, if you make instances of objects, Python uses dictionaries to implement those objects. So dictionaries are a very important part of Python. Okay, they are at the heart of Python. So what do I mean by key value pairs? First of all, let's create an empty dictionary. This is the syntax for an empty dictionary, or you can use the built-in function that also creates an empty dictionary, right? So let's go. How do you create a dictionary that looks something like that is useful in a real world scenario? So here I have created a user. I have assigned it a dictionary. So remember, this is a dictionary, right? Opening curly brace, ending curly brace. These are the keys. Then there is a colon. Then there is the value, and there is a comma. Alright. So this is a key value pair. 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 Right. So let me just verify this, that user is a dictionary, or is it something else, right? It is a dictionary, then denoted by the dict type, right? So what good are dictionaries for, right? Let's go here and let's access some of the values. So the way you access values in the dictionary is through keys. So you pass in a key and you get the value back, right? And again, like sets, it's a very fast lookup because it uses hashing internally, right? So I can say user, the subscript operator, but instead of passing an index, now I pass the value, the key. Alright? So this is how user is a dictionary, and I want to get the value of the first name, like value of the first name key in the dictionary. Similarly, I can get other values as well. Last name, age, and food preferences. Alright? Food preferences. Right? So this is how you access values in a dictionary. Dictionary, remember, is a set of key value pairs. You give a key and you access the value, right, using this subscript operator. And again, what happens if I pass in a key that is not existing, right? Let's say date of birth, right? User doesn't have a date of birth key, right? Keys are first name, last name, age, and food preferences. So the telltale of a key is it is on the left of the column. Okay, the right side of the column is the value. Left side of the column, this character is called colon, by the way, COLON. The left side of column is the key. Right side of the column is the value. Okay. So user DOB. Let's see how user looks like. User is a dictionary, right? We initialize it that way. So if I access DOB, a key that is not existent, what does it do? Right? Can anyone guess? If I pass in a non-existent key, I defined it user and I defined it as this dictionary. And if I give it a non-existent key that is not in the dictionary, what will it do? Will it give me a default value? Will it give me 0, an empty string, or a new dictionary? Key not defined. Okay, anyone else? 0, okay. Anyone else? Any guesses? Okay. So what it will do, it will give me a key error. Okay, so if you access a key that is not existent in the dictionary, you will get a key error. Okay, so what you can do is, this is a very common idiom in Python. First we check whether a key is it in the dictionary, right? Again, membership operator in for dictionary represents the set of keys of the dictionary. Okay, remember I said that these operators change their behavior depending on the data type that they are being used with. So this membership operator for dictionaries checks that if this key is it in my dictionary. Right? This is a very common idiom in Python. Key not found. Alright. Else then user DOB. Alright. So what I'm doing here is I'm checking whether a key is there in whether a key is present in the dictionary. If it is present, alright, I it's a mistake. Yeah, it should be not in, right? It should be not in. So if a key is not in user, I print key not found. If so else part is means that DOB is in user. So I'll print whatever the value of that key is inside that dictionary, right? Go back here. Yeah. So again, key not found, right? So if you want to avoid the key error, you can check if this key is present, do something, or else do something else, right? So this is a very common idiom, so common that Python has a special method for that, right? So the special method is user.get. I pass in the key, right? Again, I pass in the key. Notice that it didn't give me an error, right? I can also pass a default value here. So let's say DOB is a good default is 1990 0101. Right? Notice that what did it return? What it returned, right? So since DOB key wasn't present in the user dictionary, Python internally in this method handled that key error, right? And since the key didn't exist, it gave me this default value. So this is a very common idiom in Python, right? You do dictionary.get the key and the default value. Alright? This is a very common idiom in Python. This is to avoid this this if else block and the key error. Right? You can use user.get. This is a method on the dictionary. Alright. So now let's again go back to the user dictionary. It looks like this, right? What I can do is dictionaries by default are mutable like list. So what I can do is I can say user first name is Satya. Okay, I print user again. What did it do? It changed the first name to Satya. And also if I misspell this, suppose I misspell this as first name, right? It's a very naive thing to do, but yeah, I misspelled this first name and I assigned it to Satya, right? What will it do? Any guesses? Will it give me a key error? Will it give me default value, empty string 0? What will it give? Any guesses? keys are immutable. Alright. Alright. Anybody else in dictionaries? Okay. Yeah. Anybody else want to take a guess? If I do user first name equals Satya, what will it do? Will it error because there is an existing key called first name, the correct spelling of first name? What will it do? Replace. All right. Good guess. All good guesses. So it didn't give me an error. Let's see what user looks like now. Can you see? Can you notice the difference in this and this? This and this. Notice this now. Right. So if you by mistake misspell the key value, the key, and assign it to a value, instead of replacing that, it will add a key value pair to the dictionary, right? This is also how you add key value pairs to the dictionary. Suppose I wanted to add DOB, right? I can do this 1990 01 01. I can mutate a dictionary. Dictionaries are mutable, right? User. So again, it added a DOB and the value key value pair in my dictionary. Okay. You access the values through this, and you assign or you add key value pairs to dictionary using this syntax, right? Spell change. Yeah, it added data. Yeah, correct error. So yeah, it added a new key. Alright. Let's go back to the notebook and see if we missed anything. Keys, accessing and setting values. Yeah, so here I've in the notebook I've shown I've created an empty dictionary. So remember, this is an empty dictionary. This is a syntax for an empty dictionary. What I've done is I've added key value pairs using the syntax I just showed. Right? I've added a key called min-like pairs, max-like pairs, the domain of the centipede, which is eukaryota, kingdom is Animalia, phylum I have assigned tardigrada, but since it's the wrong phylum, I have assigned it arthropoda, right? So it will replace existing value since the key exists already. Okay. Let's enter this. Will take some time to allocate the runtime, but let's see how centipede looks like, right? Let's wait for a minute. Yeah. So it created a dictionary. First of all, it created a dictionary. It added some key value pairs here, right? And in the end, I am printing the value of centipede. Okay. Like I said, accessing a non-existent key will raise key error, right? So this is dictionaries, and again, we go back to the user dictionary. Let's what if we can, like, we've seen how we add keys to the dictionary, right? How do we delete keys from the dictionary? So dictionaries have a method called pop. You pass in a key and it will remove that key from the dictionary. Alright? It will remove and it will do one extra thing that we'll see as well. So you might have noticed that, let's see the user again. The DOB key is gone now. Okay? It deleted the DOB key, but it also returned the value that the key had in the dictionary. Okay? And again, how did I know that it will return this value? I go to the help. D.pop. Remove specified key and return the corresponding value. If the key is not found, return the default if given, otherwise raise a key error. Right? Again, help pages are important. So yeah, we have done this. We centipede from the centipede dictionary here. we pop the domain. So domain is eukaryota, and we now pop it. It's running, and yeah, it removed the domain from this dictionary, right? So we've seen dictionaries are mutable. Uh, we've seen that again. Similarly to lists, the thing that we did with references also apply to dictionaries. So to create a shallow copy of a dictionary, do the same thing as you did with the list. Pass the dictionary in a dict built-in function, and it will give you a shallow copy of the dictionary. Okay, and I've shown in the examples. You can look in the uh, notebook as well. So we've covered pop as well. So this is covered too. Dig.set default. Okay, so this is a very specific method for dictionaries. You can read what it does. It returns the value of key. Uh, this, it returns the value of key defined as the first parameter. So my dict is this, right? Uh, it returns this the value of this key. If the key is not present in dict, then it adds the key. Okay. So if A didn't exist in my dictionary, it will add the value. So again, intuitively think what set default would mean. The method name set default would mean. Okay. So if the key already exists, don't touch it, right? Return the value. If it doesn't exist, add it with this value. This is also a very common idiom in Python. Like the get method. So the get, the analog to the get method here would be set default. Okay. Dig.update. Alright. Dig.update. You don't often, it's users. Yeah. So you don't often update dictionaries, but you should know how to do that. So there is a method called user.update. Again, I don't remember what it does, so I'll go to dig.update. Right? Update D from dict or an iterable. If E is present as a keys method, then does. If E is present lacks a keys, then does this. Either case, this is followed by for K this. Right? So let's go back to the this. What is it doing? It is creating a dictionary which has some keys and values. The value of A is 1, B key is 2, C is 3, and dict1.update dict2. What it will do is it will add the key value pairs of dict2 in dict1. Alright? And remember this C is 3 currently, and this dict1 was updated with the key value pairs of dict2. So it is printing C3, right? What if I want to update an existing key? I can do this instead of using that syntax which I like discussed just now. We can do this as well, although that the earlier syntax is more clear. Right? This is when you have more keys, A's, 3 D's, suppose 10. Use these methods when you have more keys. Okay? Otherwise, use the assignment one. All right. Any questions till now about dictionaries? I'll wait for a minute. Then I'll go back to the dictionaries, hashing dictionaries. All right. Seems like no questions here. So, as as I've shown you, let's go back to the user's dictionary. User dictionary. You can see that these keys are on the left of the column. So these keys are all strings, right? This is a very common thing. Almost all of the time you'll see the keys are strings, right? But they don't have to be. So what can I put here as keys? So let's try out different values, right? You can create a dictionary very easily with the syntax that we talked about. So of course string can be keys, right? This A is a key, alright? So can I put a list here? Or can I put a number here? Is this valid? Anyone? Is this thing valid that I'm doing? I'll paste it in the chat as well. I'm creating a dictionary which has the key 1 and the value 1. Is it a valid thing to do? Maybe not. Correct? So, this is a valid dictionary. And any number can be a dictionary. Any number can be a key for in a dictionary, right? So strings and keys can always be used as dictionaries. Alright, strings and keys, strings and integers, numbers can always be used as keys. Okay, so what things can't be used as keys? Mutable data structures and in general mutable things can't be used as keys. So I can't use a list as a key. Right? It will give me the error unhashable type list. Okay? And in general immutable types can be used as keys. Right? This is a tuple. I've created a tuple as a key. Right? It's valid as a key. Right? What about set? Set of, let's say, let's give it as a list. Sets are unhashable. Alright. Sets can't. Why do you think sets are unhashable? Any guesses? Why did it give an error? Because I tried to use a set as a key. Just to not confuse you, I'll remove the list because lists definitely can't be used as keys. But what about this? Why is this not valid? They are unordered. Okay. Any other answers? I'll wait for a few seconds. Go back. Type in the chat. Alright. So the reason for sets not being able to use sets as keys is because sets are mutable. Right? We saw it. I think we didn't see sets being mutable, but you can add elements in sets. So I'll just quickly show it. My bad, I didn't show that sets are mutable as well. So this is let's say Ishan is teaching. This is tangent here, but yeah, let's cover it first and then we'll go back. This is a set, right? So teaching sentence is a set. What I can do is teaching sentence, I can add the values to sets. So sets have an update method, right? but I don't remember what type of arguments update takes and what it returns. So I'll go to the help. Update a set with the union of itself and others. Alright. So is there a method in set dot add? Right. Let's see the help for add. Set dot add. Add an element to the set. This has no effect if the element is already present. Alright. The method we want is add. So what I can do is teaching sentence. Let's teaching sentence. Right? Teaching sentence is a set. Just to prove it, it's a set. Right? What I can do is I can add elements to it. Similarly to a list, the method is called append. For sets, it's called add. So I can add Java. I can add. Let's add Java. Teaching sentence. Right? Now you can see Java is in the set. Right? So I just demonstrated that sets are mutable, right? Like lists, sets are immutable. You can add elements in sets. So that is the reason that here it didn't allow me for a set. It didn't allow for a set to be a valid key. Okay. In general, mutable objects can't be keys. Immutable things, I should say things, not objects, because objects can be keys. It's a technicality, but still, immutable things can be keys. Okay. Alright, with this, do we have any questions? Yeah, Amit, it's corrected, sets can change. So Lolita, unordered doesn't matter here. The attribute that decided whether it can be key or not is the mutability part. Alright, any questions? We'll take a 12 minutes break and we'll resume at 3. We'll start object oriented programming. However much we can cover in an hour and 30 minutes. When we add an object, does the order where it add matter? So here a good question. So when we add an object in a set, does the order matter? Right. So teaching sentence is a set. Right. Teaching sentence dot add. Let's say I add Pearl as well. Right. Again, teaching sentence. You can see that there is no specific order that it is. You can see here, right? Although this is a representation of a set, internally as well sets are unordered, right? And you can't depend on the order of sets because they are unordered. So this is the correct mathematical definition of sets as well. Sets have no defined order, right? That is the reason I added sets after sequences. So sequences, if you go by the mathematical definition, sequences have a defined order. Okay, each of these data structures, list, tuple, string, range, have a defined order. You can access its first element, second element, third, last element, right? For sets, this is not the case. Sets are unordered by default. Okay, you can't access the first element of set. So if I try to do it, teaching sentence 0, you can see that set object is not subscriptable. So there is no notion of an order in a set, right? I can't access the last element of set. Same error. Okay. when we add, okay, any other questions? All right then. So we'll take a short 10-minute break and we'll resume at 3. Okay. See you in 10 minutes. Okay. I think we can start now. Uh, Sharing screen.
Yes, Ishan, we are here.
Yeah.
So all the data types, every structure, everything is over, right? Like, can
Yeah.
we move on to hooks?
Yes. Yes. We can move on. Yes. So the rest remaining of the session today will be about hoops. Um, I think we can cover that in 1.5 hours. Although it was some time, but yeah, we'll try. Okay, so I haven't shared this. Let me just share this. Remove the dashboard.
Yeah, just put the link in the, yeah,
Yeah, I'll add
main
it in.
document, the first document, yeah.
I'll also add it in this video.
Yeah.
Yeah. So I've opened it here. All right. So first of all, let me go to the official Python documentation for classes. Uh, I would suggest for this particular page, not just this the classes one. I would suggest that not go through with this page because it's a bit complicated for a beginner. Uh, just start at the hyperlink that is given in the slides. Okay. First look at classes. Before it talks about namespaces and scopes in Python, which are not relevant to us right now and not relevant for a beginner as well. So yeah, first look at classes. So what are classes first of all? So uh, there are many definitions of what a class is, but what the definition that I like the most is that it allows you to create your own type in Python. So we've seen that there is an int type, there is a float type, a bool, right? A list. These are all the types that Python provides, right? We can create an instance of a list, right? This is this will be of type list, right? This will be of type list. So we can create the instances of these types and use them as we see fit. So what classes allow us to create our own types first of all, right? Second, they allow us to represent hierarchies in code. What do I mean by that? So, for example, if you think about taxonomy, although this is considered generally a bad example for classes and hooks, but still, it's a classic example. If you consider an animal, right? There is an animal, right? every dog is an animal, right? Every cat is an animal. Every cat is an animal, right? Every German Shepherd or every Labrador is a dog, and in effect is also an animal by extension, right? So classes allow you to represent such hierarchies in Python. Just a second. Uh, okay. So classes allow you to classes allow you to build hierarchies in your code. Okay. Let's go back to the class definition syntax. How do you define a class? How do you create your own type in Python, right? The basic syntax is class my type, oh, sorry, class my type and the word pass, the keyword pass. So we haven't looked at pass right now, but pass is a reserved keyword in Python, which means a it's a no operation. It does nothing basically. Does nothing. It's just required because of syntactic limitations of a block. Right? It does nothing. This is the simplest class that we can have, and I can create instances of it. So remember, list was a type that Python provides, right? It it is in effect a class that Python provides, which we instantiate by calling the parentheses, by adding parentheses at the end of this. So this returns a new list, right? Similarly, we can create instances of our classes as well. So what is an instance of a class? So an instance of a class is a, you can say, a realization of a class, right? It is you stamp something from a class, right? You can stamp multiple things from a class. So the thing that you stamp, you can consider that as an instance, the class, right? So my type, right? So as you can see, it gave me some weird information that it is an object at this. So what is this? What does this object do? Right? I can create a different object, and I can say that these are two different objects, right? Var is not the same as var2. I created two different instances of my class. Okay. So this is about class and instances. Yeah, the syntax is the word class followed by the name, and notice the name that I use for these classes. Like for functions, I suggested you use this snake case. For classes, what is recommended for Python is what is called as uh, snake case, not snake case, sorry, Pascal case. I had my caps lock on. Pascal case, right? This is how you name your classes in Python. So what is an example of a Pascal case? My type, right? So every word is now not separated with underscores or spaces, and every first letter of the word is capital. Okay. Yeah. Comment like in Java. In Java, right? Java follows Pascal case. I think so. Yes. Yeah. I'm not sure. I haven't worked that much with Java, although I do Java at my day job, but still. For Python, we can see that it uses Pascal case. Okay. So my type, new class, uh, dog, animal. These are some of the names that you can give to your classes. Okay. So we go back to the official documentation, and yeah. So classes, like I said, allow you to define your own types. And uh, an instance, you could also say that an instance encapsulates some state and some functionality. That is also one of the definitions of an instance. So I could define my class like this. Let's say class, what would be a good example of a class? Can go here. Uh, yeah, we can take this. All right. So this is a bit complex class, not complicated, but complex than before. Same as before, we have the class word, we have our class name, that is in partial case, we have the colon indicating that indentation is important and it starts a new block. Then we have these functions inside the class. Right? It was something like this, def parrot. Right? It was something like this, right? Def word followed by name and some parameters. Okay. So this is a function. What's special about it is that the function is defined inside a class, right? So this function is defined inside a class. Greet function is defined in this class as well. By the way, these functions have a special name. We call them dunder methods. I think I talked about briefly uh, a while back. Dunder methods, or some people call it magic method, but I don't like that name. There is nothing magic about it, right? Just I like to call them dunder methods. Some people also use special methods. Right? Some people like to call same thing different names. So I call them dunder methods. So what's special about dunder method is they start with an underscore and then a name and end with an underscore. Okay. So if you are in an interactive session in Python, or just go and do help on any data structure, let's say list, right? You will find it a class, right? So see the similarities there, right? Class this, and we should go to help. It's class list. Don't worry about this. This is an remnant from Python 2. We don't need it in Python 3, so you can ignore this. So this is a class, and this class has some methods defined, right? These are called dunder methods, right? We talked about them just now. So you read this as dunder add, dunder contains, dunder del item, alright? So dunder wrapper. So what these dunder methods are, these dunder methods allow you, is my Wi-Fi working? I'm audible, right?
Yeah, you are audible.
Oh, okay. Showing this, it's not connected. Yeah. So these dunder methods allow you to hook into the Python language and make your own types behave the same way as a native Python object would do. So for example, a native Python object is a list, right? It comes with Python, right? I can stick it in a for loop or item in list, pass. It will do nothing, right? Because there is no item in list. So how do I how does the in operator work with list? What defines that, right? How do operators work in Python in general? And the answer is the in operator, the functionality of the in operator, you can modify and check with a special dunder method called uh, dunder. Not in would be a bad example. Let's say plus operators, right? Uh, this Ishan plus plus Python. Alright, this is a list of this is two lists with having each a single element. If I add them, you can see that it created a new list. So what indicated that the plus operator for list would add the elements of the list, right? How do I specify that for my own objects, for my own types? So to read that, you can go to help list and go to dunder add, right? It's here. It's dunder add. So what you can do is you can override this dunder add, or you can define this method inside your class, and then you can take over what plus means for your instances, right? So you can choose how your objects behave in Python. Alright. So a very good example of this is NumPy and Pandas. You'll see them in future sessions. They overload a lot of operators in Python, right? And then they implement that logic in C. So it's not at all executing Python there when you add to NumPy arrays. It's executing that logic in C. But what NumPy has done is it has defined a custom object that it has defined a dunder add method such that when you call the dunder add, it goes into the C language, does the addition, and then gives you the result back, right? So this is how you extend Python. These dunder methods are how you extend Python, right? And these also are responsible for providing some basic functionalities, like when you print something, what gets printed, right? So for a list, for an empty list, the square brackets get printed, right? So for your objects, what does get printed, right? You can control that using methods like dunder wrapper, dunder string, right? Dunder wrapper, dunder string. These control the representation of your objects in Python. When you are in a REPL, when you print your objects, or when you use them in an F string, how does that object convert to something printable or presentable, right? So these dunder methods have various features. Each one has its own intricacies that you can explore on your own, right? For this, for our first class, my first class, notice that we have defined, we'll read this as dunder init, right? So dunder init is of course a special method. It's a dunder method which is called when you instantiate an object. So let's go to the class. Let's define it again. Just to, I've defined my class again, and what I can do is, right, I can instantiate an object of a class, right? I told that earlier as well. But what if I did this? Remember this, first of all, let's read the error. Type error, my first class dot dunder init, missing one required positional argument name. So if you notice, we received the same error when we tried the parrot function, right? So this is a normal method, right? The only special thing about, this is a regular function. The only special thing about it is that it is defined inside a class, right? Functions, we call those functions methods. So this is where the distinctions between methods and functions come. Functions are lone functions that you define outside of a class. Methods are functions that you define inside a class, right? And so first of all, let's remove this error. My first class expects one argument. So let me pass this argument. I'll pass it Ishan. Right? I'll pass it Ishan. And it returned an object. So that is what is getting printed. So let me just say it equals object. And so what would have happened is, when I call this thing, when I execute this class, the dunder init method automatically gets called, and the arguments that I pass here get passed after this self parameter. So this self parameter is a bit special. I'll talk about it, but this name is now equals to Ishan, right? And inside the dunder end function, what I do is I type self dot name equals name. So I'll explain the self thing just now, but you can see that what I passed inside it got assigned to the name attribute of this object. So another definition, anything after a